Hey everybody, this is Larry. This is me going with Q3 of the bi-weekly contest 153 minimum cost to divide array into subarrays. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. So this one I thought was actually ultimately a reasonable problem. During the live portion, if you watch, and why I didn't solve it during the contest is because I thought that it required this trick that I had to learn. I mean, I knew of the trick, but it's not something that I practice, and I don't know that I've ever done it. I mean, I read about it and I knew the ideas, but I've never done it. Maybe I need to do it one of these days, and we'll go over that trick as well. So with these problems, I find it useful to kind of just do the naive thing first, right? And for this one, n is equal to 1,000. I knew that there's going to be an n cubed solution. And I also knew that n cubed would be too slow, right? N to the third power. But I wanted to just write it out because for me, I thought that there'll be an optimization. But for me, I'm not good enough to visualize the optimization without looking at it in code. You may differ. You may have a different process, but that's how I do it. And anyway, so that's the way that I started out. I go, okay, well, yeah, this is just dynamic programming, right? Memorization, dynamic programming, whatever. And the state seems pretty straightforward. And this is basically it. I'm going to index, this is I, and just based off the index of the nums, and I is the I that we care about in this formula, right? And so, yeah. Sorry, I'm like I have allergies, so I'm like trying to process through it a little bit. But in any case, yeah, so index, if we ran out of elements, then we're done, is return 0. Otherwise, we want to minimize the score where we just go to the right, right? For every index, we have this cumulative sum. You could use prefix sum to get it. But yeah, this is just the implementation of the formula, right? You have the prefix sum. We actually did a prefix sum here. I'm going a little bit fast. This is a hard problem, and a hard problem with a few prerequisites. So the parts that I'm going a little bit fast, my apologies, but it also might mean that you need to work on dynamic programming problems in general. And I don't mean that to be mean. It's just this has a bit of ideas, right? And this is a hard problem, so yeah. Anyway, so given that this is the prefix sum, and this prefix sum just allows us to get this part, right? And actually, let me put this formula down here so I don't keep on scrolling. Right, so we have something like this, right? And the prefix sum will allow us to get this part of the formula, the plus k sub I. Well, I named it k times I, so I said plus I, but k times I, and then times total, and total is just the cumulative sum going from left to right, right? Yeah. So total we start at 0, but you can also implement that with prefix sum, and it's the same idea. I don't know which. Sometimes I jump around ways, and maybe this way is actually worse because it's a little bit harder to visualize. But yeah, and then after that, you recursion, right? Okay. As I said, I'm not gonna go with this explanation too much for this particular DP, but because this is pretty standard if you're able to do this. If n is equal to 100, I've already been submitted. It's in a couple of minutes. It's done. The next thing that I optimize is that I go, okay, well, maybe we can optimize this loop array. Because this is n square. Index is 0 to n, I is 0 to n. This is 0 to n, n cubed too slow, right? So there are only two things we can try to optimize a way out, and for me, unfortunately, I try to optimize for this loop. The next parts, they are concepts to learn for different types of dynamic program problems, but it turns out that it's not the right way to do it for this problem. But I just want to go over it to give you ideas to research further. So that this coming part will be a little bit fast anyway, but you can also feel free to skip forward a little bit to the way that I end up doing it after the contest, unfortunately, but still. Yeah, so the first thing that I did is that I was like, okay, maybe I can optimize this array. But I know that if the idea here, and I didn't have the complete idea yet, but the idea here is that, and I'm trying to bring up the drawing board for visualization, right? And the way that I think about these problems is that, okay, we have a grid, right? Let me. I need like a pre-drawn grid or something. But yeah, and this grid is the dynamic programming grid, actually, right? Oops. Also, I want to say that I didn't solve it this way, but this way is correct. It's just that it requires stuff that even is beyond even me, which is for better or for worse if you ask me. But just saying. Okay, so then this is a dynamic programming matrix, right? You can think about one of the dimensions as index. I'm drawing with lines. Okay, one of the dimension is index, and the other is I. And in this one, let me take a look at the code real quick. Yeah, so given some index and I, we basically need I. In this case, the way I wrote it is I plus 1, but then like a suffix of all the index plus 1s, right? So it's something like this. That means that this result depends on this column, right? And and as a result, and we'll come back to it in a sec, but yeah, as a result, I wrote it bottoms up so that I can kind of take advantage of it, right? Because on top down, there is actually a way to take advantage of it, but it's usually, especially for n square things, it's just not fast enough for Leetcode. So I usually just convert it to bottoms up. And also with bottoms up, there is space optimization, which would make it faster. Why does space make it faster, you say? Because n square space takes a lot of time to allocate, at least on Leetcode for whatever reason. Right? So okay, so I rewrote it. This is exactly the same. Nothing to it, right? And then the next thing that I did, I was like, okay, let's see if we could optimize out this loop, right? And of course, during the entire way, I just make sure that the inputs, at least for the examples, are correct. Yeah, and then I kind of converted to this, right? So I have this, I converted to this. How do I do this, right? I actually, if you watch the live portion, you'll see me actually doing this live. But the idea here is that, okay, so I have this formula, right? Or this thing, oops. Right, let's actually create some things first. I have it on screen, yep. Okay, so again, so yeah. And you'll see here that I actually have this total thing, but I lied because I don't use it. Because I did the prefix sum on the cost so that I could split this out, right? So this used to be total, right? You kind of look at here, this is total, this is the same except it's total, but then now I convert this to use the prefix sum. So I actually technically don't need this anymore, but, right? So we have this loop, right? And we have this loop now. And then now that prefix sum this out, well, the couple of things that I realized, which is that, yeah, we can do the distributive property, right, for this formula, and then if you do, I don't like the syntax, so I'm just gonna show it real quick. So like this, right? So here, distributive property. So you have something like this thing times this times this thing. I mean, we could distribute it twice if you like, right? So distribute this plus k times I times this thing, right? So you have this, right? And again, you could distribute it again, but yeah, but that's basically the idea. You have prefix r plus 1. Okay, let me just copy and paste, maybe. Right, so you have this times prefix. This is a prefix c, not prefix. The prefix on the cost, right? Minus this part multiplied by this part, right? Still distributive, right? And then you add by k times I times this part minus k times I times this part, right? And okay, so and with experience, this is not an easy thing to do, I don't think, honestly, but with experience, so you have this thing, right? And here, I noticed that, well, this is a constant, right? For every, like, if you have index and I as in the cell, right? Well, this is a constant. So that's how I can take it out. So I took this out and I put it here because this is the constant. It is inside the minimization loop because we're trying to minimize this function for all index I and R, which is 3 dimensions. So we're trying to reduce the dimension. But first I remove this and put it here, right? So that there, now we got it. And then now we also realized that this part and this part and this part only requires I and R. Because I is in our outer loop, we can just also take it out and pre-process it to be used next time, right? Or for the next row. So that's what this column, this row does, right? So then we remove this, and then we remove this, right? And then now we're left with, this thing, and that's how we have this formula, right? And that's okay. Not done yet though, but it is going to be the end of this road for this type of solution. I took like half an hour, or maybe even longer, to try to figure out how to do this. And honestly, I kind of knew, but I was hoping and trying to figure out if there's another way to simplify this. But maybe I should have gone with my gut. And we watched the live portion. I actually talk about this immediately, which is this convex hole trick. And for this trick, you can actually, there's a good code force article. You can probably just Google for this, really. And it'll give you a visualization. But the TLDR is that you can think about each of these as, so you think about each of these as some number, mx plus c, right? So this is the c part, yeah, and sorry, I'm like sneezing real badly. And this, and this is the x. Oh no, this is the m. This is the slope, and this is the x, right? So yeah, and as a result, you have all these lines, and then all you have to do is just combine them to get the minimization of that loop. I'm going really fast because honestly, I have not done this before, so maybe as an upsell in the future for myself, I would do it. But I just want to get the explanation out. But once you realize that, then you can do the convex hole trick. Also a stupid name if you ask me. But yeah. Anyway, it turns out though, it is not necessary for this problem, so I'm going to go ahead real quick. Anyway, going back to here though. So now that we're back to here, the original top-down DP solution, this is still n cubed, so I was like, okay. And honestly, this is after the contest, so it's not, I mean, it's a virtual contest, so it's not cheating anyway. But after the contest, I was like, okay. My chat was like, oh no, you don't need convex hole trick. And I was like, huh, that's interesting. So then I was like, okay, well, if you cannot eliminate this loop, then there's only, you have to either remove index or I, and it doesn't make sense to remove index because you just need to keep track of the beginning, like partitions. So maybe we could think about removing I. And then the thing that I was thinking of, and I was just kind of trying new random things, is that I have, so you have this formula, right? And as we could do the distributive thing again, which is that you have, and here we have the OR loop, so we don't have to worry about it, but we're trying to eliminate I, right? So then here, this part times this part, we're going to calculate anyway, so we're not worried about it. But let's say we have k times I then, right? So we have k times I times this thing, the total. But we could write it out. So total is going to be cost. Actually, I'm just copy paste from here, right? Right. And one way that I would think about it is that the first time you do it, what is it, right? It's going to be just 1 times this thing, right? And then now, what's the second time, right? Well, and now the second time is going to be, right? It's going to be, I'm going to say, the way that I align this is for a reason. It's going to be R, let's say L sub 2, right? And then R2, right? But keeping in mind that if you line them up like this, L2 is equal to R plus 1, right? Makes sense, right? Hopefully. And you could also line them up more. Maybe I just squeeze it a little bit so that I have more space for another one. Yeah. So, okay. So the reason why I draw it like this is, and hopefully you'll see in a second. And then K3 is equal to, well, this thing, but maybe to, this way. And here we sum up these 3 components, of course. Oh, this is a 3. So what is the thing going on here, right? Well, because this is K times 3 by geography, you could say this is K times 2 times this thing plus this thing, right? And also by the same logic, right? You could take another one and put this here, right? And you already see what I'm doing, which is that we can take this one, put in a 1, and then modify it to here. All right, it doesn't line up anymore, but you get the idea, right? Yeah. And that's it, right? And if you, as a result, when you see this, what does this say, right? So now actually the I goes away, right? We don't care about the I anymore. It's all just K times whatever. It's K times 1, but yeah, there's no more I dependent. And as a result, and we just have to calculate this thing, and this is just the suffix sum, right? Because this is all the way from cost all the way to the last element, and that's it. And that's how I did it in this particular problem. And I actually, during the live portion, I actually did this as well. But yeah, excuse me. Yeah, I did the suffix sum on the cost, and then I just do the K times this, and we don't care about I anymore, and that's it. It's a optimization, and don't get me wrong, I did not get this during the contest because I was focused on the other way of doing it. But yeah, and this is going to be n squared because the index goes from 0 to n, and here there's just a loop of O of n, so this is n squared, and that's it. That's all I have with this one. Let me know what you think. I thought this was a very cute problem. Let me actually put this on the other one. I thought this is a very cute problem after I realized it does not need the Convex whole trick, but I was honestly very frustrated during the virtual contest because I was like, oh, come on, Leetcode, what CHT is unnecessary for anything, really. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and you can watch me try to solve it live and also upsolve it afterwards and all these things. Now, spend too much time. Okay. Oh. Sometimes you get a happy surprise. Well, we have 2 hearts. What is that? 6 and 7. All right. And how much time do I have even left? So 10 minutes in. Climbing up the leaderboards. I mean, this is cheating, I guess. How dirty? Oh, I don't know. Oh, I mean, luckily I clicked on the problem that I already solved, but that's they shouldn't let you do that, but okay, fine. Okay, focus. Minimum cost to divide arrays into subarray. Nums into subarrays. You're given 2 of the same size. So it's the total. So it's the 0 to the right side. So prefix sum times array sum. Subarray sum. Prefix sum times subarray sum plus this variable thing. This thing is just silly. You can just kind of prefix it in, but just add the numbers by k or something. Okay. I represent the order subarray. Oh, I is the subarray, not the I of linear. Okay, so maybe I'm wrong on that one. First subarray. Okay, so here, this is a very wonky function. Don't really know what that means. N is 1,000, so I suppose there's a DP. But I am cheating already because people. I did see that people take a little bit of a long time. Not that long, but long by Larry standards. or if the good people are taking that long, it'll take me even longer, is what I mean. Not that I have higher standards. But okay. Okay, so this, I mean, it is DP, right? Okay, I think the first thing to do is probably just write the naive DP. I think this is a DP optimization thing that I always try to do by thinking it, but I have to write it out. It's been a thing that I need to do more often. So there is the current index and then the current I, which is very awkward. Whatever, okay, fine. It is in definition, I suppose. Okay, so if index is equal to the no number of I limitation, so okay, so and we return 0. So I'm writing this code very much knowing that I'm not going to use it, because yeah, this will be n cube probably, but I think there's probably an optimization somewhere that I need to write out to see, because I'm not good enough to not do it. Okay, I mean, this is just, we need a prefix sum. That's fine, yeah, prefix sum. Right. Okay, and then we also need a second prefix sum. Okay. Though this one, maybe you could do whatever. Okay, fine. Okay. That one we can do on the loop. But okay. So then up we okay, let's do a regular thing, right? We start from index to n. We want to, so what is this? So we want, what is this formula? So prefix of nums, so just prefix going to j inclusive. No, it's j plus 1 inclusive, because we want this to be the right side, so let's actually use this variable. Okay, so this is this plus 1 plus k times I. We start I as 1. Okay, fine. So okay, so this is the prefix sum. We multiply this by the cumulative sum, which we can use this, I suppose, but I actually don't. Is equal to 0. Cumulative sum cos of not index of right, and that's it actually. Oh, okay. I need, statistics background sometimes die hard. Okay. So that's the total cost plus go of r plus 1, I plus 1, right? And then that's it. And we max this. That's it, really, right? I mean, obviously not, but I mean, that's it for the n cube one. 128. Okay, that's not true apparently. Am I oh, this is a 1. No, I think I overcounted, so I don't think that's quite the fix. Prefix of times total, that seems right, right? Okay, 52 for the first part, which is not right, and I don't think that would be right. Why do you have 52? I mean, that hopefully that's just a arithmetic error, but no, that doesn't even make sense. Maybe. Debugging is expensive. Don't do it, kids. Don't get yourself in a place where you need to. Okay, let's just get rid of this. Give me. Okay, so this is. What is this saying? This is. Oh, wait, no, I did that. K times I. Okay. So this is 5 on this plus 10, right? Or times 10, so this is 5 times 10, so how did I get 52? Do I have my index wrong? Plus 1 should be right. Huh? Oh, I don't know. This is 0, so okay, so where's the 2 coming from? Oh no, it's one from here. Cause so what is this move? 0, 1, you choose 1, so then it'll be, maybe that actually makes sense for one element. Man, I can't even get this right. What am I doing wrong? Is this right? Alright, 1, 1, 2 is right. 1, 2 is 36. Because you have 6 times 6. This is 2 times 1. So then this is 6. 36. Okay, maybe that's right. Then why am I wrong? And this is the dumb part of the problem too, and I can't get it right. That's a little bit sad. Okay, 144. What am I doing wrong? Oh, minimum. Why am I maximizing it? Well, I mean, that would make the problem harder when you're maximizing what should be a minimum problem. Okay, then it's definitely not 0 for, okay. I have reading problems. Okay, so now this is right. Okay, so can I figure out how to optimize this code knowing that this is n cubed? So what does this look like? This thing is fine. This is pretty straightforward. What is this thing? Given an I, k times I don't change, right? So then it's just a prefix of this. Okay, so total, does total change? Total is the cumulative sum, but also maybe, is this a easy thing to fix? So, okay, so I mean, is this like another just put it in a sig tree thing? Can you just dump it in a sig tree? You're minimizing the suffix, so you don't even have to do a suffix tree. It is just a suffix. Okay, I mean, this is pretty straightforward actually. It's I mean, it's annoying but straightforward. Okay, right. Okay, so then now we have this code. Okay, let's actually open another window. Oops. And the reason is just so that I can write it bottoms up. I think I have to write it bottoms up. Okay, I was trying to think of maybe I don't need to. Okay, and then base case is if I cannot go over n anyway, so whatever. Okay. I think you can definitely do a space optimization thing, but I don't want to prematurely do it. Okay, so then now, I'm just so slow at this. Alright, let's run it real quick just to make sure that I know out of bounds, okay, because it's very easy to, and I'm a silly boy. Okay, 4. This is just so annoying. I'm really bad at these. It's not that annoying actually. That's why I could get people get in 10 to 20 minutes. Okay, so here we have, I just write it out first for correctness. Okay. Yeah, okay. Okay, and then dp of index I is equal to best, right? Right. Out of bounds. Where am I out of bounds? Oh, I plus 1. I should not go over n. Can it be n exactly? I guess it can be n exactly actually. So okay, this is way wrong. So we made some mistakes here somewhere. Oh, I did it in the wrong order. Did I? Well, I mean, definitely yes, but why is it so, like, why is the answer so weird? Okay, fine. Oh, oops. Okay, that is even more wrong. I looked at, oh, I am way wrong. This shit indexes are wrong. Maybe, what did I have before? This doesn't make sense. Why is the total here? Okay, so that's maybe why it's wrong. Okay. It is still wrong, but less crazy wrong. Yeah, I don't know why that is, but this is still wrong though. I do need the index to go the other way. I plus 1 is ready, or in this should be right, I think, maybe. Also, we don't need this. I am too slow for this these days. Oh, it's index. Is this right? Yeah, if it's index, then it's all plus 1, right? And these things don't change. In fact, this contribution don't change really, so it's just prefix. We can take, but that's an optimization. We can take it out later. Why am I getting it wrong? That's why I need to do it every step of the way, because I'm too silly to. Do I redo this? I do redo this. That's why. I redo the base case. Oh, I do redo the base case though. I don't know why the answer wouldn't change. Should have changed at least a little bit. I guess it just never happens when this is going to end, so maybe that's why it doesn't change. But then now, you still have to work it out for me, Larry. And also, maybe just a slight optimization. Oh, this is also in the wrong order. I am not a smart boy. Yeah, okay. Okay, there we go. Today, I'm not a smart boy. Okay, so here, that's fine. What we want to do is take this out, right? K times I times total, we can take it out as, I don't know, whatever, sum I. Okay, that's not right. What did I do? K times I times, oh, because total is prefix sum. Okay, so I can't do that. It's not like that. Because total is the subarray sum. Okay, so then now, okay, so this is correct with too slow. Then now what? This part is easy. This part, how do I fix this part? Actually, maybe I lied about the prefix sum. I think the cumulative sum is always harder to read, so maybe I'll rewrite it to, where is it? Prefix C of R plus. The current index is index. So this is R minus this, right? Is this so right? Nope. That doesn't make sense though. Okay, actually that's fine, but somehow. Oh, this is +1 and this is +1, so yeah, okay, fine. Okay, so we're still good, but now we have a thing. So you have this thing. So we want to do a suffix max, maybe? Yeah, okay, so then you have this, and we are happy, kind of, right? Now we want to post-process it. How do we post-process it? Can we post-process this? Am I really dumb today? I mean, maybe, but because this thing is changing on the right side, this is on the left side. I mean, you could distribute the things. Yeah, I mean, okay. I think I'm thinking too deeply about it. So then here, this thing is a constant for, now it is, this is tricky, right? There's like a suffix thing here that I can do, but I'm not quite doing it right. Oh yeah, let me also make out another window just to kind of save progress. Okay. Okay, so we have this thing, right? How do we forward calculate this? I mean, the K times I. Okay, so we definitely could take out the k times I, and so we could take this out. Okay, let me rewrite this as I can't do this in my head anymore. So, okay, plus okay, minus also minus though. Okay, right? Still right? Okay. So this is still right. And then now this is a suffix thing. All right. If this is the right side, okay. This is a suffix thing. This is a constant given index. What am I missing? The all plus, I can't figure out all plus one part easily. I'm just too dumb today. Okay, so yes, let's say you fix this, right? And you have, how do I roll this in? Or is the troublesome part? Okay. I is fine. We have I, we have index, so we don't have R. How do I roll that in? It feels like a suffix thing, but I'm so bad today. How much time do I have left? 54 minutes. This also feels like a classic skip to the Q4 problem, but I'm kind of stubborn today. How did I get rid of this R? Well, we got rid of the total, so we don't need that anymore, just so. And also in theory then, that means that n minus 1, index minus 1, this should also work. Maybe that's a little bit, that's not right. Maybe it goes, nope. Oh, index minus 1, because that's to do index. Yep, okay. So then, how does this rolling? Am I missing something? I don't think there's anything else, is there? Okay, so this, so if we try to minimize, this part is easy. This part is doesn't change. You can take that out and it'll be fine. You can take that out and then you can just say right? Let's see if that, just to kind of make sure at least that's still right. Yep. So okay, so that's fine. And then now we have to kind of add these parts in to do the min. This changes, so we can do a roll. If we do a prefix rolling thing, this only changes one at a time. Is that enough? Because then now we only have R's. Maybe? I mean, this is a constant giving R anyway, so. I'm just not seeing the connection, the relationship well. So okay, so given the index and I, we want to minimize this stuff. Okay. Maybe I need to just draw it. Maybe that's what I should have done anyway. Okay, so you have so this is the stuff that you're minimizing. You have some constant, okay. What is the R in this case? TP's R. I think this is the troublesome term because this part an index. How can I take this out? Let's say we iterate, right? We're getting ready for the previous thing. Is it only getting used by one thing? Maybe that's what I'm missing. I plus 1, okay. So that means that it's not getting used by any other i's. And all the, okay, let's say I have a different index. Different index doesn't change the R's, and then you can or should be able to reconstruct. Right, so then you could calculate it forward. Right, okay, so if I had to rewrite this, something like for R in range of I'm getting distracted. Okay. So this is index I. Right. So that means that here we are at I. What does that mean? We want to say we want to set it up for the future, which is dp of R sub I. We want to add it by, say, prefix R plus 1 times prefix, right? Does that work? Yeah, I mean, I think this should. As long as I is not 0, maybe. If I is not 1, or maybe we just skip 0. I don't know. This feels like something like that is needed, but I'm not doing it right. Yeah. Maybe I need to do it the other side. Pre-process this, so then it's actually all plus. I don't know why I had this like this, but something like that. Would that make it right? Yes. Okay. So that's the progress we want. And this can be taken out as well, then, right? Yeah. Okay. This is what I want. Okay, that's what I was looking for, but I was struggling so hard on this. Okay, and then now we just have to minimize this thing, right? Without I don't want. So this is going to be trouble some point, but at least we got it this far. That was 10 minutes. 45 minutes. Okay. Okay. Focus. We got this. What does this mean? So given an index, we min over this, which is fine. And if we be able to min over this, then it's straightforward. And given an index, what does that mean? What does it mean? Prefix of C. What's prefix of C again? Oh, that's right. And we took out everything else, so that's the left bound. So that means that for each OR, I feel like I'm close, but okay. It's indexed to R, the relationship, that's the tricky part, right? Okay, so how do I get rid of it? Huh. Okay. I mean, we're definitely closer, but I knew that one of these, I forget which, I mean, I didn't realize which one yet, but I knew one of these was going to be the issue. But can I rewrite some of these? Given index, prefix of R plus 1, what does this mean? Can we rewrite this in index? Can I rewrite this in index? R is just equal to, this is the prefix. Okay. How do we get rid of another layer? Though maybe I already did. Maybe this, no, this is another part, Larry. This is the prefix, right? So the prefix Okay. Or is equal to index plus something. That doesn't help, I don't think. Prefix of index. This is like some reverse. Do I need like a different something? So for each index, we still have this function. I need to either roll this into this or something. Or what is or? Or also doesn't need to look like this. I just kind of wrote it this way just to prove that the order doesn't matter on that. Okay, does that help? So given the index, okay, so let's say we have one of these, right? This multiplication is weird because then we want to do a suffix of this. That's easy. In fact, we can take it out. Can we? No, there's an R in there. Can we up the prefix of? Is either take this out or this out. So for each index, we have to correspond prefix C as we go from greater to smaller. This gets smaller, so that means that is this like some convex thing? Where I mean, I see the relationship, but maybe I should have skipped ahead. This is kind of tricky. I mean, I see how people might have gotten it, but I don't know. A lot of people took a long time actually. Actually, but the only 20. Oh, this isn't right. Oh no, just that more people got Q4, but not everyone got Q3 and Q4. So I spent a lot of time doing this. Oops, not even looking at the right one. So even if I get this, I'm probably not gonna have a high rank. I mean, this is virtual anyway, but because I didn't do Q4, and I only have like half an hour. Okay, let's see if I could focus this out. I don't know how to work on this though. This is the minimization of this and this thing. This thing is easy for a suffix. Is there a suffix way around this? I mean, this. You just have to combine them. Okay, so is there even like a suffix tree E thing that we can do in one operation? What would that even look like? So given a prefix C, because now you have like a lot of linear if we think about this as a line, then this is the slope. No, well, this is the slope technically. That's too hard for me to figure out. How do I minimize this? Yikes. You have to, it's a combination of these things, so you cannot separate them out. Can I express or let's see. And of course, this is just equal to no, maybe not. I don't know. Let's skip ahead. All right, let me take a quick peek at Q4. Kind of sad about it. Oh, is this the? Oh, it's a only 22 people got this. Okay, fine. Maybe I'm not looking at Q4. That's all I need to know. Maybe. What am I missing? I feel like it's staring me in the face. I'm at half an hour. All plus one. Can I take this out later? No. This interaction, I don't know how it is. I thought I might be able to take care of it, but and is there some sort of weird pigeonhole thing? No, that doesn't make sense. Some water. I mean, 400 people got it, so it's not like it's impossibly. But and I got most of it. I feel like. But this part. So we're minning R. We're minning R. Is there a way I can substitute this? Do I subtract every? I have to do a lookup here, right? And then get them in, which is not makes sense. Can't take out the index, can I? Okay, can I take out the index? I mean, no, because that's how we got in here. Is this prefix cost thing? Is that we have this, yeah, this thing, we took it out to stick with here. Could I have done it with suffix? Or is that just, no, then you would, if I do it with suffix, does that change anything? No. No, because it just depends on, you still have to figure out where you crop, which is also the R part. Because you need to, oh, it's not a constant in the index and I. Huh. Man, I am confused. And this is not a good time. Prefix. I don't even know which one I want to get rid of. Well, I can maybe. Can I rethink about this? Okay, prefix of C of index only changes a little bit, but because we need this. So, okay, so there's a delta, right, from the previous thing. That means that every number we subtracted by this thing, which we cannot do in QuickTime, I don't think, because it's dependent on index, a prefix of an index. Is it a suffix tree thing? I don't think so. I don't think there's a login thing for it. You just have to update all the updates, right? Huh. Am I doing this wrong? Is there some sort of greedy for this idea? So I'm just curious. Is it 52 or 50? Oh, yeah, it's min, that's why. Min should be 50, okay. But is there a thing that we can rely on? The K times I part is a little bit awkward for sure. Is there a tighter bound that gives us timing? Is that how? Is it branch and bound? No. Man, I have no idea. And I feel like I'm so close, but this part is not that close. I mean, I think this is. You have this slope, so it's like a binary search on this. Is it just convex? How? I mean, I feel like that's how we do it. Okay, fine. Let's skip ahead because I feel like that's it, but I'm not. It's been too long. I don't know the idea behind it. It's been. I'm not practiced enough. Because do you binary search on the thing? Or I don't remember how to do it. Okay. I guess that must be it, but that doesn't mean I know how to do it. Okay. Yeah, I mean, you have this relationship. Okay. First principles. Can you solve for this? Right, so okay. I don't know how to do this. I know the concepts, but I never done it. So I guess this is one of those classic Leetcode. It will never be an interview thing, but yeah. Okay, because every time you move up, okay, so for I we look at r minus 1, so then I don't know it well enough, to be honest. Because basically the idea is that, okay, so you have this thing, and then I guess I just don't know it well enough. How much time do I have left? I have 22 minutes. But I feel like this is most of the answer. It's just that, like, I know of it, but I just thought maybe there's a easier way, because this is stupid. Like, it's not an interesting problem as a result. And the worst part is that this is a Q3, so it just blocks you from doing Q4 if you feel like you're close. Like maybe it's a Q4, it's fine because you've done everything else, but that said, Q4 is supposed to be harder. So I don't know how much of it is that people just solved. Yeah, just assume that this thing is right. Okay. What is the slope? Okay, visualize. Okay, maybe I don't do it for now. Maybe I'll upsolve it afterwards because this is just kind of stupid. Okay, fine. I think it is right though. But yeah, okay, fine. Hang on. Yeah, so I'm back to doing Q3. I still have this thing where you have Convex Hull, but I've been thinking about it a little bit. And yeah, I'm still trying to observe it, and so I'm not gonna lie. I did get a hint that I did not need the Convex Hull trick. I don't know that I want to implement Convex Hull trick because I've been looking for the other trick anyway. But if you want a tutorial, you can Google for this. I think it's pretty informative, and you can kind of work this out. I don't think it's super bad, honestly. But it is a little bit, yeah. I mean, it's, you know, like you can figure it out, but it's not so bad. Especially if you have a lot of time and you're figuring it out. But as I said, I did get a hint that you don't need a Convex Hull trick. So let me kind of revisit what I want to do here, right? So let's go back a little bit. We have this thing, and maybe even this thing, right? The other way, maybe we can get rid of the I. What was the I, right? So I is going to be K times I, and can we get rid of the I? Yeah, I think that maybe that's the other way to think about it, is try to get rid of the I, and we need index anyway, right? So then how do I get rid of this? It's gonna be some K times total. What is total? Total is cumulative sum, right? And yeah, suppose we have to get rid of this. How do we get the I away? I mean, this is the only other way, right? Because, well, yeah, otherwise you do the Convex sum part. But how am I able to get rid of I? Again, well, we did say that we can get rid of this by taking it out, right? Yeah, we can do this, and then it's going to be best plus K times I, right? But this is still correct. Right, let's keep the I in here for now and see if we can optimize this a little bit. Okay, we already kind of messed this up. Oh, I plus 1, whoops. Okay, still already, wait, let me, oh, K times I plus times total. Oh, the total is not a thing though, right? So, okay, so maybe I lied there anyway, but okay, let me rethink about this for a second. Okay, just to make sure that we're still right. If we are able to get this to n squared, then we have to get rid of an I. There's no way to get rid of index. It doesn't make sense. So that means that, okay, what is this, right? So K I starts at 1, so it's going to be K times the total. What is the total? I feel like that's just like the expansion that we wrote somewhere here, right? We have this thing. Okay, so let's see. I is the order of the subarray, I times K. So you definitely can take this out, but then it is the subtotal, right? So the subtotal So this is cumulative sum. It's gonna be k times I, and then basically every step you go, you get a cos sub r difference, right? How do we do it? K times total. Oh, is it like a suffix thing? Do we subtract out or something and then we get it? Okay, what does the suffix look like, right? So, okay, so here we know that we have to consider these in the future. So, okay, so that means that you have this formula. Okay, let's see. So let's say you have this formula, right? And we only take account. Okay, so it's this plus this, right? And now we no longer have I in here, right? So that's fine. And we have here, right? So that we have to minimize. But then now, if we do it all the way through, right? So then if I is equal to 1, then it's just this. If I is equal to 2 on the next one, it is, I don't know, cos sub r plus 1 plus 2. I don't know. We ran out of variables. So let's call. Alright, let's just say. Variable names are tough. Let's just call it A, right? For whatever reason, right? Does that even make sense? No, because I'm drawing them awkwardly. Because then now you could draw them like this, right? Maybe. Yeah. So what does this mean if we align them like that? Well, that means that this is just this, but this goes here, right? And then now this is just suffix. So then now this becomes this plus k times suffix of cos, suffix cos from r, no, from index. Is it index? I guess so. Yeah, it would be from index, if I do it correctly. But yeah, I don't know. I want to be precise on this one. That's why. Okay, so suffix. That way, yes. Okay, something like that. Okay, I feel dumb on this one actually now. but all right. Okay. A little bit slow, but we'll see. That's ridiculous, but I mean, okay, fine. I take it back. This problem is pretty fine. If you need CHT, it's annoying, but I think this one's fine. I was thinking about the suffix for so long, but just wasn't able to get it. Needed a break, I guess, to come back to it. Because I was thinking about suffix, but I guess I was only thinking about suffix on here, on the idea behind Convex whole trick. Because I really thought I needed the Convex whole trick. Because, well, I mean, this is what this part looks like, right? So, but I didn't think to eliminate the thing, and once you write it out, I guess it makes sense, right? It's just that, like, we have this visualization, but I kind of just, I didn't think to eliminate the I, honestly. I thought that, I got stuck thinking of just, I mean, I didn't think it would require the Convex whole trick, but I thought that, I would need it. Or like, I thought that I can reduce it to something like this and then just magically get these things out without the Convex whole trick, but so I didn't go down the right way for that reason. But yeah. Alright. Yeah. I'm going to take a break again before doing Q. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, and my explanation, everything in between. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.